Okay, last thing to talk about is misleading graphs because you're going to see these a lot, especially in media. So let's look at the different types. So obviously when you're creating a graph, you want to make it simple, clear, and well labeled in order to avoid misleading your audience. However, you're going to see a lot of times when the media is trying to mislead you or a business or whatnot, they're going to use these different types of graphs to make things look different than they are. So for example, a pictogram. So we really want to stay away from those. So what a pictogram is it's a statistical graphic in which the size of the object is intended to represent the frequency or size of the values being represented. Unfortunately, we often perceive the relationship between the proportion and not just the heights of the graphic. So between we'll use area and not just the height. So again, if I was looking at this graph, should just be looking at the heights because this 63% should be a lot closer to the dollar. And 54%, 48%, 39% are not that far off from each other. However, because a pictograph uses the area, it has this width in here. This dollar looks almost twice as big as the 63 cents. Okay, now let's look at another example, a misleading scale. So a misleading scale, if the baseline of your scale is set to something other than 0, it's considered an exaggerated scale. And so just so you guys know, I actually pulled, all of this stuff was pulled from things that are out there on the internet. So for example, here's a misleading scale. And so we can see that support for same-sex marriage. You can see the frequency on the left-hand side where it goes from 0, the scale is from 0 to 100. So you can see those that oppose and support are pretty close, like 40-something%, almost 50%, and then a little over 50%. However, if you change the scale, so instead of starting at 0, I'm starting at 40, look at how different this data looks. Oppose looks so much smaller than support. And that's because they're only looking at this chunk. So when you just take that chunk and blow it up, it looks so much smaller, those who oppose it versus those who support it. But that's actually not the truth. So again, when you're seeing these examples and these graphics coming up in any media that you're looking at, always look at the scale and really think, are these that much different? Is this 4 times different than this one? Because it kind of looks like it is based on how much taller it is. And in fact, it's not. You can see there's only a 10% difference between the two. This one's at about 45, this one's at about 55. All right, let's look at another example, stacked graphs. You're gonna see these sometimes. So let me put in what a stacked graph is. Okay, so don't look at this second one yet. Let's look at this first one. So this first one is a stacked graph. And so with this stacked graph, you see what they've done is they've had student 1 in dark blue, student 2 in light blue, and these are really difficult to read. And it's because the values are kind of comparing, they're stacked on top of each other instead of side by side like in this one. So, okay, so if I'm looking at student 1 versus student 2, it's really hard to see the difference between student 1 and student 2 here. Whereas here we can really see that difference in rent. Food, again, since those are stacked, it's hard to see that, oh wait, they're the exact same value. Tuition, those are stacked, so it's really hard to see that exact comparison. So again, pay attention when you see a stacked graph and try to see if you can convert it to a side-by-side chart so that you can really more easily compare. One last thing, just a few other cautions about graphics. So perceptual distortions. Many graphics are drawn in a way that distorts our perception of them. So again, that pictograph was a perfect example where we weren't just looking at the height of the dollar bill, they put the entire area in there. So they added a width in there that made that $1 look more than twice as big as that 63 cents, which was inaccurate. You want to watch the scales, as we showed with that oppose versus not oppose for same-sex marriages. So it can be visually deceptive if you do not study the scales carefully. Percentage change graphs can be extremely misleading because graphs show the percentage change, so you've got to just really interpret them with really good care. And then again, we talked about those pictographs, so they're graphs that are embellished with additional artwork. And although that artwork can make it look more appealing, it can usually distract or mislead you. So we're going to end up doing a project in here where you guys are going to go out and look in the media and try to find graphics that are misleading using some of these types of things.